So, until the headset is working, I'm going to take this one. So, this talk is about SMS. I'm doing the talk together with Nico Golder, who is my student at the university. And yeah, so we're going to show you some funny stuff about SMS and feature phones. So university students, we did some stuff in the past. Uninteresting. So first I will give you a short introduction about the topic. We'll talk a little bit about SMS. Then Nico is going to do the stuff about our fuzzing setup and fuzzing results. Then we're going to show you some additional fun we had with network operators, and then we're going to show you some attacks, and then at the end, just some short conclusions. So, as you know, mobile phone security is like a really, really hot research topic. Everybody's doing it. Some people doing protocol level attacks. Crypto A51 is a very popular topic. Application level attacks on smartphones, like owning web browsers, whatever. And of course, SMS in the past was always interesting. We had, like, I think 2 years ago, stuff with this curse of silence. So you get one SMS and never get another SMS. So SMS is kind of cool. But nobody ever looked at feature phones. So feature phones are these phones for 50 bucks. So the basic talk, or the talk is basically about SMS insecurity on feature phones. So by feature phones, we have about 4.6 billion mobile phone users or GSM users in the world, but only about 16% in the world use smartphones. So yeah, smartphones are interesting because all the geeky people have one, and if you go to a conference, everybody has a smartphone, but if you look in the real world, everybody has feature phones. Of course, the 16% it's really average around the whole world. If you go in the Western world, like West Europe or the US, the percentage is higher. But in general, feature phones are the things you want to look at if you want to do large scale, and that's feature phones. So what is actually a feature phone? When first mobile phones came out, this was a small phone that only could do phone calls and SMS, and then they started to add these additional features and created feature phones. So you have a web browser now, an MP3 player, and the thing is, most of these phones cannot run native applications. You only have this J2ME or Brew stuff. And the other thing that's interesting is they have only one single CPU. They normally do that for cost reasons. Because feature phones, they want to have like maximum features, minimum costs. And why feature phones are really still popular is the price. They are so damn cheap. And even for like a decent feature phone, if you get like a contract from an operator, you still get them for free. They have very good runtime, they're very stable, so if you drop them, they don't break immediately, like with many of the smartphones. Feature phones have some very interesting properties. First, each manufacturer, like Nokia or Sony Ericsson, normally have really one piece of software that is used for their entire line. So even if they build 50 different feature phones, the software inside is really everything the same. So our first theory was, okay, if you find a bug on one device of a manufacturer, probably the bug works everywhere. And therefore, we can very easily create an attack, or a bug very easily becomes very huge. And the second thing is, since you only have one processor, if you get the application to crash, we most likely are able to crash the whole phone and make the phone reboot. But now, since there are many manufacturers in the world who build feature phones. So the point is, how do we select the right one for an attack? Because we cannot look at every mobile phone or every manufacturer, and it doesn't make sense if a manufacturer only has like very small market share. So what we actually did, we just went to like these market research companies and checked, okay, which manufacturer has which market share. And we first did that just for the world, so we just checked, okay, what is the share around the world, and we said, okay, let's check Europe, and maybe the US and Germany. That was just the interesting things for us because we are from Germany. Germany is in Europe. Okay, Europe is, of course, in the world. And yeah, if you want to like publish in an academic conference or any conference, having the US in is just nice. So here you see basically Nokia, Samsung, LG, Sony Ericsson, Motorola, basically in all markets. That's the device, the manufacturers you want to look at. And since we had, or I still have, like a colleague from India, I asked him actually to buy me a special Indian phone because India is a very uprising mobile phone market and it would be just fun to have a very popular device from them. So this is Micromax. Really nobody knows it, maybe besides Harald and the other GSM people. But it's very interesting. And market shares are really nice, so if you want to like build a targeted attack, maybe against a specific operator in a specific country, you just go, take the market report, choose the targets based on that report, and that's basically how it works. So in order to actually do some testing, you actually have to buy phones. Phones, like if you buy them without contract, they're kind of expensive. So we started going through eBay, and like even like since the phones are like that good and they work for that many years, like even if you get a new phone after 2 years, you can easily use a decent feature phone for 5, 6, 7 years, maybe with just replacing the battery. So what we did, we just went after these really nice broken phones, because instead of 60 euros a phone suddenly becomes like 5 or 10 euros for a kind of recent model. And some additional nice, interesting thing we found is, phones don't really have a hard reset functionality, which got a real pain later in our research. And you find really, really disappointing things on phones you buy on eBay. So really disappointing. And the problem is we could not delete them ourselves. So it was, if you go to the SMS inbox was okay, but other stuff was not that funny. So, okay, so why SMS? Because there was so many talks recently on SMS, and so we thought, okay, we really have to justify why we want to do SMS again, because it would be much more fun or way cooler if you go like on the low level, on the baseband, on the radio interface. But we thought, okay, what is the one feature that's common to every phone? SMS. It really works everywhere in the world. So as an attacker with an SMS bug, I can just go to, I don't know, some island if they have GSM coverage, or even just PSTN connection. I can just attack any phone in the world. I don't have to carry my base station and sit like 10 meters or maybe 50 kilometers next to him to attack him. I can just sit anywhere in the world. Also, SMS is so feature-rich that you have so many things that can go wrong. And many implementations implement really every feature, but basically there are like 3, 4 features which are regularly used, so you have really a ton of untested code. And last but not least, SMS is processed by the phone the moment it gets a message from the network. So you don't have to like go to your email application or web browser and click something. It's a really true remote bug. You can just fire it, and as soon as you switch on your phone, if it's off at all, we can own you. So, but the other thing, when we went to and started to analyze the phones, first to check out, okay, we need to look inside, look at the software, and of course we did not have the source code because, of course, company secrets, and why should any manufacturer give out their source code for free? Then second, you don't have native applications. So normally if you don't have native applications written by third parties, you don't have an SDK. And if you don't have an SDK, you normally don't have a debugger. That's really, really bad. So of course everybody says, use JTAG, it's so simple. But actually for doing stuff like that, JTAG is not that simple. JTAG is nice if I want to like unbrick my router. But hooking up JTAG to 10 plus different phones, there's nothing you really want to do. Also, of course, reverse engineering is nice. If you have a specific target, you go and reverse engineer it. But if you have a lot of different phones and firmware versions, you just don't want to do it. Or you want to, but you just don't have the time. So with this, I'm giving off to my colleague, because he's going to show you how we did the analysis and shows you the awesome bugs.
Okay, so as Colin already said, debugging the phones directly is no option, and also reverse engineering is totally out of reach for quite a number of phones. So the solution we came up with is using the other side of the peer-to-peer connection, which in our case is the GSM network. Using your own GSM network for SMS analysis also has quite some advantages. First of all, sending text messages is free. We can send as many messages as we want without paying anything, which is not that kind of a problem, because there's bulk SMS providers that allow you to send lots of SMS really cheaply in the internet. But it also has the advantage that these operators are not eavesdropping on our payload, so we keep all our 0 days to us. And also an important point is that it's way faster to send messages over our small network. In a real GSM network, there's quite a lot of routing overhead involved that we don't need and don't want. But probably the most important point is that we have full control over everything. We don't just lose messages and have no idea what's going on. We can track every state the message is in. And we can use the communication between the phone and the network to do some analysis. We decided to do fuzz-based testing because we don't have the source code and we can't reverse engineer. And this way we create a test case once and can test it on every phone that we are going to test. And I don't want to say much about fuzzing, but what's obvious is that it's not worth much if you don't do proper monitoring at the same time. So when you're running your own GSM equipment, this was traditionally not very easy because the GSM industry is rather closed. While the protocol specs are available, even if they consist of over 1,000 PDF documents, you won't find any public documentation about involved hardware or equipment, and even acquiring equipment was not that easy in the past. But this has changed recently with the development of OpenBSC, OpenBTS, and Osmocom BB, which is a set of software that is used to run your own GSM equipment. And we decided to use OpenBSC to drive our network in this case, which is a free implementation of the ABIS protocol, which is used for communication inside the network. And it's implementing a small subset of features that you need if you want to run your GSM network. And also important, it supports the NanoBTS and the BS11, which are base transceiver stations that you can buy on the public market. So the setup we used looks like this. On the left you see my notebook that is connected over Ethernet to the NanoBTS in the middle, which is our small base station, which costs like 3,500 euros if you buy it on the market. And on the right is just some phones that we tested. So that's a very simplified version of a typical GSM network. The most important component is the MSC, which is the mobile switching center that is responsible for everything related to routing, call establishment, handover procedures, and such things. And it's connected to the BSC, which is the base station controller that is in charge of managing the base transceiver stations in a certain geographical area. The base transceiver stations is just what's known as the cell tower, and is basically the entry point to the network for the phones, and is doing all the radio-related signaling. So if you submit a message to the network, you do this in SMS submit format. The encoding differs depending on if you submit the message or if it's delivered. The message is then passed to the mobile switching center, which looks up the destination network using the HLR, which is the central database inside the network that is storing all the subscriber information. It's the home location register. And if it acquires this information, it forwards the message to the SMS service center, which is responsible for storing and forwarding SMS messages in the network. If the subscriber is not attached to the network, it stores the message, and if it's available, then the message is transmitted over the it's transmitted over, so the SMSC actually does the HLR lookup to find out the destination MSC. It delivers the message to the MSC. This is then doing a lookup using the visitor location register, which is a local database used to store subscriber information for a certain area. And then the message is transmitted over the air using the SMS deliver encoding. So OpenBSD by default already supports SMS messaging. It supports sending messages from one phone to another, which is not that nice for our research, but it also provides a telnet interface that allows you to inject messages, but it's limited to only text messaging. We could enhance this, but like I showed, this is not a very good option. Also, it's rather slow. And it's only working for an attached subscriber, so if a subscriber is attached to the network, you can send a message, the channel is opened, the message is transmitted, the channel is closed again. But if it's not attached to the network, it's just discarded and it won't be stored anywhere. Also, it features a command that allows you to send all stored messages at once to subscribers, but this is not really what we need. We want to send to individual subscribers to be in a better control position. So what we did was introducing a new telnet command, so we could inject pre-encoded SMS submit messages into OpenBSD, which are then stored in an SQLite database. And we also had to introduce some relaxed message checking because OpenBSD by default rejects pretty much everything it doesn't know. This includes messages that are encoded as compressed and such stuff. So if we fuzz SMS, we likely have lots of invalid encodings that we need to get through OpenBSD somehow. The important part about fuzzing is the monitoring. So we've added various logging stuff. First of all, the phone is submitting feedback back to the network, in which it lets the network know if its memory is full or if it can't accept a message because there's a protocol error. And the important thing for fuzzing, if we want to see if a phone just crashes, is that we have to track channel release dates. If a message is sent, it goes over such a logical channel, and if it breaks down, we have to know in which state this happened, and also we have to be able to map this event to a message that might have caused this. This is an example of how the log evaluation looks like. It's just noticing that the phone went offline, and it's finding out the message that might be responsible for that in the database. So messages are sent over logical channel. On the network side and on the phone side, the GSM stack responsible for this is usually divided into 3 layers. This is you have the connection management sublayer, the short message relay layer, and the short message transfer layer. It's not too important what kind of packets are sent between those, but what's important is that the relay layer on the phone side creates a packet in which it lets the network know if the message was accepted. In this case, it sends back an RPAC package, or it sends back an error message that also includes the reason for the error. So we want to log this one, and we want to also log this packet which encapsulates this error or acknowledgement packet and is sent over the air. And this is exactly what we have to track. If the channel breaks down, this packet never arrives at the network side. So like Colin said, we can't do much modifications on the phone, but we decided to do one modification on the phone. And this is used to find state fuck-ups, like in the case of the curse of silence attack, in which your phone still accepts the message but just swallows it, and they never reach the user interface. So what we did was writing a small J2ME application, which is supported by pretty much every feature phone. At least I didn't see one that doesn't support J2ME. It binds to an SMS port, which is kind of similar to typical IP ports. It just processes messages that are addressed to a specific port, and an incoming message that is addressed to this port just creates a message back to a special number. which we can then use to see if the count in the database for this special number increased or not. If it didn't increase, we know that the application somehow swallowed the message and some strange thing happened. So we injected one of these messages, like every 10 messages we send, we then check in the database if the count increased or not, and if not, we check in more detail what happened. So this is basically like a typical message looks like in hex encoding. This is just encoding a simple hello world string addressed to 1234. It's not that interesting. You have 1 byte that specifies if it's a submit or deliver message, and it's also setting various other options. You have a message reference that is used to be able to map errors reported from the network back to a message on your phone. You have the destination number, which just consists of 1 byte for the length. This 91 is a type identifier, which in this case identifies the number encoding as being international standard, and the number is then encoded in swapped nibble notation. And yeah, then you have 1 byte for the protocol identifier, which is used because SMS originally was designed to interwork with other systems like fax or email. And this is used to set which interworking is being used. And this is also an interesting field to fuzz, because it's likely to trigger old code that has never been really used in practice. Then you have one field which is the data coding scheme that encodes a certain message class that is used for this message. This advises the phone how to store and how to display the message. And it also encodes the GSM alphabet that is used to encode the message. So SMS usually can be 7-bit, 8-bit, or 60-bit encoding, depending on what kind of characters you want to send. Yeah, then the validity period is not interesting, but what's interesting then is this is the user data payload, which encodes the text you want to send, which in this case is a 7-bit encoding of a hello world SMS. So yeah, that's how an SMS looks like in PDU format. So this was a simple text message, but SMS can also be more complex. It has a feature that is called a user data header. These are just simple small chunks that are added similar to IP headers and add additional control information to the message. This is an example for it, which is used for 60-bit port addressing. It just consists of a type identifier, a length field, and hex-encoded port numbers. And there's all kinds of other stuff you can do with the UDH. It's used for concatenating messages, so multi-part messages. It's used for port addressing, sound, SIM toolkit, and various other stuff. But what's interesting is that you can also combine these things. So that's really where SMS becomes a bit more complex, at least more than simple text messaging. So this is a more complex example of an MMS notification that gets sent over SMS. It consists of the previously mentioned source and destination port, UDH chunk, a multi-part chunk, and you have various variable length strings encoded. You have a content location, which in this case is just Google.com. You have a from field, and yeah, this is interesting it's showing that SMS is really more complex than simple text messages, especially because it can also consist of various binary encodings. So the test cases we concentrated on, we obviously couldn't test every feature that SMS provides. It's really quite a lot of features. We concentrated on multi-part messaging, which in this case is the UDH for multi-part messages, which just contains a simple reference number that is used to assemble the messages on the phone. It contains a number of all the parts, and also a current chunk ID. Also, we had a look at MMS notifications, because these are sent over SMS. If you receive an MMS, you usually receive a SMS that contains the actual URL of your MMS content, so you can download it. And it, like I said, it consists of variable length string fields, so we were targeting typical buffer overflows and memory corruption issues. Also, we fuzzed simple text messages. Like I said, 7-bit encoding is what's used for this, and usually you have a GSM alphabet and some kind of array that is used to look up characters. So we produced lots of simple text messages that will likely result in null pointer exceptions if the encoding is looked up in such an alphabet array. Also, we had a look at flash SMS. This is an SMS type that is interesting because what it does is you send a flash SMS to a phone and it directly pops up on the screen without any user interaction. You don't need to open a message. And this is interesting because the code path for this is usually totally separated from the normal SMS application. You have this overlayer screen, and it's likely that if you have a bug that isn't triggered in the normal SMS application, it might be a bug in this Flash overlay. And Flash also can contain various other features like the multipart that I already mentioned. Then we have this TP-PID, TP-DCS values that I mentioned, which are in control of how the message is displayed and stored on the phone, and combinations of these are likely to trigger not often used code paths. And yeah, we were just looking for unusual behavior with playing with these values. And altogether, we generated 120,000 messages per phone. We didn't test all of these if we already found a bug before, but that's quite a lot of test cases. So yeah, we've written a small Python library that is creating all these messages in submit encoding, and we submit these over our introduced telnet interface into the OpenBSC SMS database. Then we just pick a phone number that we want to fuzz, we open a channel to it, send all messages through it, and afterwards close the channel. So this is a fairly fast procedure, at least faster if we use the existing text interface, and every time we send a message, the channel is open, tiered down, for every single message. And then we use the script that is evaluating the produced logging from OpenBSC to, for example, flag invalid messages, so we don't have to again and again send messages that a phone is not accepting and is reporting as protocol error back to the network, and we can sort these messages out. And we also used this to map channel breakdowns to the SMS that might have caused this. So the complete setup looks like this. On the left side, you have the Python library that is generating the messages. They are injected into the OpenBSC database, from which they are delivered over this nano-BTS to the target phone, which is running the J2ME server to check for state fuck-ups. Then you have the logging from OpenBSC and a separate script that is evaluating this logging and mapping it to certain SMS messages. Yeah, for those who wonder, we don't have a GSM license, but we also don't need one because we have this fancy cage. But yeah, from what I know, it's not too difficult to acquire a GSM license, like the guys here at the Congress did. So yeah, we did a lot of fuzzing. It was quite a lot of work, and while pretty much everything of this was fully automated, we had to delete messages by hand. We could have automated this, but the problem would be that we would need to develop, or we would need to configure things like Gamu, which is a software you can use for deleting messages for every phone manufacturer, and this would again be no platform-independent solution. So we decided to rather take the pain and delete the messages by hand. And also, we quite often had to get phones out of stuck states. We had to do lots of hard resets, and yeah, phones really behaved weird. We have to somehow manually monitor it as well. So the kind of bugs we were looking for this presentation were bugs that allow you to disconnect the phone from the network completely, or maybe even reboot, and thus also cause a disconnect from the network. So let me show some bugs that we found. The first one is for Nokia S40, which is Nokia is the phone manufacturer in the feature phone market, and S40 is the operating system used on these kind of phones. From what we know, this bug will pretty much work on every S40 phones except the really new ones, because Nokia accidentally fixed this bug, unfortunately. But what happens if you send an 8-bit class 0 message, which is such a mentioned flash message, with a certain user data payload, the phone just shows you the Nokia widescreen of death, which is just a flashing widescreen. The interface completely reboots, thus it also disconnects the phone from the network and interrupts existing calls. But what's interesting is that the message is never acknowledged. Colin will say a bit later about why this is interesting. And the message is totally silent. If you are a victim of this, you don't notice it. You just notice that your phone is starting to behave really weird. And what's nice about this bug is that Nokia phones inside have a watchdog that is monitoring for such crashes. And if this happens for like 3 times in a row, the phone just shuts down. So by sending 3 messages to such a phone, you can switch it off remotely. Okay, next one is Sony Ericsson, also quite popular in the feature phone market, and especially in Germany. It's a really popular phone. Most of the people know these Sony Walkman handies that are very common. And like in the Nokia case, what happens if you send one of these TP-PIT values? I don't want to drop the payload here because it would just make not much sense. But there's certain protocol identifier values specified in the GSM specs that are reserved. There's like 7 values, and if one of these is used with a certain length that is exceeding a certain value in the user data, what happens is also that the phone completely reboots. Thus it's also disconnecting from the network, calls are interrupted, and like in the Nokia case, the message is also never acknowledged back to the network. More later from Colin then. This message is also not visible on the phone. On some phones that we tested, they occasionally just freeze completely, so they didn't reboot, but the phone was just in a locked state. And one of our test phones also broke during playing with this bug. We didn't invest this in more detail because it would cost quite a lot of money to test this. So next one is LG, not that popular, but like I mentioned, MMS notifications consist of these variable length fields. So this is a classic buffer overflow in processing these fields. If you just play with these a bit, the phone also completely reboots, which if you have a pin set, also causes you to be permanently offline from the network because you have to enter it, and if you don't notice it while the phone is in your pocket, that's pretty bad. So also a disconnect from the network, interrupting phone calls, and depending on how you craft the payload, you can also achieve the same thing if the message is opened on the phone. So it can happen twice. This is why we already said that reversing was no option for us, but this would be an interesting target, I think, if someone of you wants to find the first code execution bug on a feature phone, then this is probably a good target to do debugging and reversing. So Samsung, these are also pretty famous or pretty common. They make these fancy phones that look a bit like smartphones, but are nonetheless feature phones. So what happens if you play with the multi-part headers that I already mentioned and use, for example, a chunk ID that is higher or way higher than the overall number of chunks, you can manage to get a message that is displayed as having a very huge size on the phone. The phone just displays how big the message is in bytes, and with one single message you can achieve that the phone displays a message that is a couple of megabytes big by playing with these values. If you open this, the phone also crashes, network is disconnected, but what sucks about this is that user interaction is needed because the message needs to be opened, which is not that big kind of a problem if you want to carry out a large-scale attack, because people who receive SMS will also likely open it. But there's another issue with the same payload. If you modify this, you have a situation that is very similar to the curse of silence bug. What happens is that starting from the point of receiving this SMS, your phone will never ever show an SMS message again because it will simply deny every incoming message with a protocol error. Also, this message is silent, you won't notice it. And what's also interesting, that for whatever reason, the phone application and the SMS application on the phone is also not working anymore. It just shows you a screen that is saying it's loading, but this never stops. So in my opinion, this renders the phone pretty much useless, except for incoming calls. Yeah. Also, we've had a look at Motorola phones. In this case, the Razr, Rocker, and SVLR, they are a bit older, but still very popular. I've even seen some of them here. And the previously mentioned protocol identifier interworking is what we use in this case. if you specify an internet electronic mail interworking, which is a protocol identifier value of 32 in hex, and combine this with some payload, the phone just shows you a flashing white screens, the user interface completely reboots, and thus also network is disconnected and phone calls are also interrupted. I couldn't fuss these phones more in detail because they behaved rather fragile. One thing that often happened to me is that when you send multi-part messages and leave just a chunk that is a chunk out of such a multi-part sequence, the phone starts to store the message and is not showing them in the user interface because the chunks haven't all arrived yet. But the memory is full nonetheless, and since you don't see any message, you also can't delete one. And what also happened is that after playing with this bug, the phone just occasionally also showed the same behavior and produced lots of false positives, so it wasn't really possible to fuzz this in more detail. Yeah. Then we have this Micromax phone, which is, like Colin mentioned, the third biggest manufacturer in India, but not that common in Europe. The phone arrived quite late, so we only could test it very briefly because this was brought by our colleague from India to us. But it also showed that it was not really, it was also a rather fragile device. So the same happens like in the Samsung case. Also you have the multi-part headers that you can play with this time, but with flash SMS. Like I mentioned, this is a different code path. So this bug doesn't happen if you do normal multi-part messaging, but just with in combination with flash message. So what happens is also that the phone is not flashing white this time, but it just blanks out for a few seconds. The network is disconnected and phone calls are as well disconnected. The only constraint that you have is that the reference ID that you use in the multi-part chunk has to be unused, but that's not a real obstacle because flash SMS is not very common in normal text messaging, and this is a 1 byte identifier, so you have basically plenty space to pick a value from. So I think we are going to show a demo now of these bugs.
Yeah, so demo, so just video demo because normal demos never work, and we really want to show something that actually.
And even this one has a small bug in it.
So, okay.
This phone won't work.
So we just roll it, and we're going to pause in between sometimes. So first, we are just going to, we just send some text SMS so every device blinks up once. So we just see, okay, it's really working. So, yeah. So now every phone just blinks once, besides the one white Sony Ericsson phone, which disconnected during the test from the network, but this is not a problem since we actually have two of them. So the first one, Nokia, white screen of death on the right side, just goes.
Yeah, in this case the phone just comes back, but if you repeat it more than 2 or 3 times, the phone switches off, which we didn't in this video.
So then we just take Motorola now, since it's just the same. So you actually see that it says, no, you don't see that.
It says kein Dienst, which is no service available.
Yeah, so besides blinking white, it really loses network. So the second Nokia in the middle, the battery is very low and the display is crappy, so the white screen is really a gray screen, but same effect. So yeah. The more impressive one, because you just see, it just immediately reboots. And so, another white screen. So the LG still is rebooting. Maybe it's manufactured in Villarriba. So the Micromax really just blinked very shortly, and the Sony Ericsson just finished rebooting. So yeah. So the interesting part is really every phone just disconnected from the network.
And except the LG one, because in this case we used the variable length string fields, all of these things happen with just one SMS. In the LG case it was, I think, 3 messages. So yeah.
So it's, yeah, it takes, should be pretty cheap. Let's stop that. So then we started, so when at some point, some months ago, we started, okay, this looks pretty bad. And so we started to like contact some people, and Nokia was lucky because I just know a few of them from cons, so it's good for companies to send people to cons because then they know people who break stuff. So we told them about it, and that's actually how we know that everything besides the very latest stuff from this year is affected. It's very nice. So with Sony Ericsson, that was, emailing them was a huge pain in the ass. It was like a really total fail. But then at some conference, I noticed the name tag from a guy, and yeah, then yeah.
And even afterwards, it still was a pain because they couldn't even open messages that were PGP encoded because they were sent to a specific email address. So, yeah.
And it, yeah, I know. Well, I think they said like it took them 3 weeks to just like confirm something. They didn't tell us what they could confirm, but they said they could confirm. So security at Motorola.com. So the Motorola has a really nice website for security. So if you Google security Motorola, you get this nice page. End users, please call this toll-free this free number. Independent security researchers, please write to security@motorola.com. But yeah, I think nobody reads that email.
Oh, I even got a bounce on the first mail sent there.
So for Samsung, LG, and Micromax, it was kind of difficult to actually find people. So they have like O-Day today. So besides making fun of vendors, we actually played a little bit more with the whole thing. So what Nico showed you earlier with the nice bugs from Nokia and Sony Ericsson is where the phones don't acknowledge the SMS to the network. So the network believes the SMS is not received. So your phone crashes again and crashes again. So really simple fix is just take the SIM card, put it in a phone of another manufacturer, not another phone, another manufacturer phone. Doesn't help if you move one Nokia to another, the phone will still trigger. So,
and this phone also has to accept the message. In the Nokia case, I had some problems finding a phone that will accept the message.
So we thought, okay, let's check if we can abuse that a little bit more. Because, yeah, attack amplification, you know, like the old Smurf attacks where you send one broadcast IP packet and on the one single cast IP packet, and on your local LAN it becomes a broadcast. So just some amplification. So we thought, okay, let's check how how an operator actually does the retransmit. So that's what we actually did. We just took one of our Sony Ericsson phones, hooked it up to a Linux PC over Bluetooth. We just connected to the dial-up network service and just check if the Bluetooth link goes away, because if the phone reboots, the link should go away. Then we hooked that up with, of course, you need to power it if you actually run it for like a week or so, and constantly power it up, power it down, and have Bluetooth running. Of course, you have to swap the SIM cards because we're really interested in what all our German operators do. And then we found this. So you see, 0 is when we send the initial message, and then after 1 minute, everybody retransmits, and then for some time, you have a retransmit every 5 minutes. And some operators then go to a bigger backoff sooner, and some others like do a little bit more. and even like T-Mobile and Vodafone.
It's a bit bad to see the pink line is the T-Mobile and
So
Vodafone
actually
line.
the small line here is E Plus and O2, and T-Mobile and Vodafone is the others. So some guy told us, oh, nice graph, so they use the same equipment because that's default settings. So yeah, so you actually see they even do retransmit after 2 hours or in 2-hour intervals. And of course, after we didn't like really stop completely testing, or actually we want to do it, but then I forgot the phone in the office, and then I saw, okay, there we have more retransmit like 20 hours or 24 hours later. So it goes on for, I think for 2-3 days once.
Yeah,
one test.
so
for
I sent one of these messages to a colleague which then complained that her phone was bricked, even if it wasn't. It was just this SMS which was constantly knocking off the phone from the network.
So what you can do now is just like send 3 of those messages with like 10-minute and 10-minute timings, because then you actually get more messages. And because normally you think, okay, SMS will be queued up at the operator, but if they fail to deliver, they get their own timer and are transmitted individually, which is very nice for making nice attacks. So then we thought, okay, what to do? Like, yeah, clearly the attacks can be, or the bugs can be abused or used, whatever, for attacks. We can just disconnect your phone call. So, of course, you only have to send the SMS to one side if both are using a mobile phone. So we can make sure that you're not reachable. So, yeah, it could be worth the money for some people, but if you have a Nokia phone, it will get cheap, and maybe, yeah, we can switch off the phone and it will get even cheaper. And then we thought, okay, because we said we want to do large scale. We already have large scale because we have more or less every popular operator. Then we thought, okay, how could somebody make money or have a little bit of fun? So in Germany, it's very easy to like get phone numbers which are connected to a specific operator. You can now, of course, migrate your phone number to another operator, but say maybe 10% do that, you still, just by the phone prefix or the area prefix, it's still pretty simple. So script pretty just says, okay, let's make, I don't know, operator pink or operator blue or operator green look really bad, and just like disconnect some people from, some of their customers from the network. Of course, the guys from, I don't know, I don't want to say Russia, but you know, the guys in multiple countries around the world who like to do online scams and DDoS, they would, I'll go to the operator and say, hey, give us some money, otherwise your customers will suffer. And of course, then you will suffer too, because they might leave you. And so one thing we would really like to try out, which is a little bit hard, is to try to, what happens when we disconnect like 10,000, 50,000 customers from the network at about the same time, and everybody comes to the network constantly and tries to reconnect and to re-authenticate. So it would be interesting to see what happens in smaller countries, because there was a talk, I think last year or this year at Black Hat, where they actually made it for, got some network equipment part to fail just because of too many requests. So if we could, just by attacking the customers, knock out the operator, that would be really funny. And of course, if you can make an operator look bad, we can make a manufacturer look bad. So we say, hey, LG, do you want to have a lot of phones shipped back to you? Do you really have like a good customer service department? Let's try that out. And of course, then, yeah, I don't want to say cyber war, but yeah, if you want to like carry the attack more to the public and maybe some big outdoor event where you know, okay, there will be a lot of people from Germany, whatever, then you can probably cause quite some trouble if for some part of time nobody can use their phone. And as far as I know, in many countries, also in Germany, the police still carries a cell phone because their two-way radios are not working that good everywhere. And if you can disconnect people there, you can cause some trouble. But yeah, sending messages in quantities that actually start making fun is not that easy, because yeah, you can use a phone, hook it up to your computer, and it's very slow. and pricey and traceable. So, okay, then you can go to like a bulk SMS operator. And so these are the guys who send SMS spam for you. Basically, you just give them money, a message, and a list of how many, like 5,000, 10,000, 100,000 phone numbers. They will deliver this one message to all phone numbers. It's very cheap. They don't ask questions. If you can use Tor and have like a prepaid credit card, tracking should be pretty fun, pretty hard for them. And yeah, the injection rate is pretty high, which is good if you want to do a lot of in parallel. Yeah, this is just some our favorite guys. And actually, our total favorite is HSL.
Yeah, HSL was so nice to give us a phone call to help us with constructing payloads to send over their network.
Yeah. So the best part from HSL was not all the operators or not all the bulk operators support to set every bit of the SMS they do. After we asked them to please configure us the feature. And of course, yeah, so smartphone or mobile phone botnets were like a big thing, and if you remember the last year small issue with this SSH password on iPhones, on jailbroken iPhones, so yeah, I think 20,000 phones have been infected, so you would have to you should have been able to like send 20,000 SMS in parallel if you were the owner of that botnet. Much more interesting, but also very hard to get access to is SS7, the good telephone infrastructure protocol. So if you have an SS7 link, you have like, compared with all the other methods, a really high speed interface. You can do a lot of injection. The price is probably really good. It's hard to trace if you don't get the SS7 contract by signing something with your real name. You don't really have any limitations. And yeah, but yeah, you should know somebody, or yeah. But if you're like an operator, like in an interesting country that want to like make fun of another interesting country, then you could.
So we don't have SS7 access, but if someone knows how to get it, please talk to us afterwards.
We have phone number lists, that's not a problem. So, of course, everybody thinks now, okay, we told the manufacturers they will make updates for all your feature phones so you're still safe and don't have to like buy some other phone or return your phone. But the problem is price always. Feature phones are made for price, so manufacturers don't offer really updates. Some do here and there, but not for every model. And the other problem is branding. So if you get a phone that boots up and shows you like your operator logo, that's like a branded firmware. And branded firmwares normally can be only overflashed with another branded firmware. So if you make an update, the operator has to make a new branding and so on. Will take time, will never happen. Also, there's this net lock or SIM lock, so that you only can put like your SIM card that you got with your phone into the phone, or only SIM cards of that operator. And a lot of unlocking or net unlocking has been done with modified firmware updates. So the operators just thought, okay, no more firmware updates because we don't want people unlocking your phones. But even if you get an update, how do you know it? Your iPhone tells you, oh, you have an update, please install. Your Android phone will probably update the phone without asking you. But your phone will never tell you. And normally you have to go to a desktop computer, plug the phone in, download it, install the crappy application, which only works for Windows and never works anyway. Or even better, you have to go to that one store in your city to get it flashed there. And like we tried that for some phones, but we couldn't even find a store in Berlin. So yeah, that won't do it. So most of the bugs, I guess, we showed will stay for quite some time. And everybody can have a lot of fun with it. So basically the conclusions from our research are that now with the openness of GSM networks on the network side, you have the awesome stuff made by Harald and all the other guys on the Open BSC and Osmocom and the people from the Open BTS project. They opened this one site, so now we can look at this closed stuff. And yeah, if you are able to look at closed stuff, then normally it breaks. And what was really interesting, and not like, well, I wouldn't say shocking, because we actually thought it would be a real fuck up from everybody, that all of the major manufacturers have bad enough bugs that it really should bother them and probably a lot of other people. Since it's so many phones, all operators, everywhere around the world, we probably can say somebody can do something large with that. Yeah, if you're an operator and do retransmits of SMS messages because they cannot be delivered, that really is great for helping with attacks. And I don't think you need to retransmit a message 10 times. I think normally that doesn't happen too often in the real life. I don't think your battery will fail 10 times in a row. Yeah. Yeah, and the fun part, which was the actually only part we could not test in real life because it could really get us into trouble, is if you can actually, by attacking the users of an operator, make the users go and attack the operator back, or their phones do that. So that would be the really interesting part, which I think should work in some circumstances. And yeah, manufacturers really should start making firmware updates for feature phones and advertising them to the customers in some way. Even if your phone just shows a stupid pop-up with go to the store and get an update. But yeah. So that's it for now. Thank you for your time.
Just one question, Colin. Don't text me, please. Do not do that. Does anybody else have questions for them? Wow, a lot of you. And I guess I have some mission angels as well. Where are you guys? Or girls? Yeah, you have some questions too? I propose we do... Okay, please, people, either sit down or exit quiet so we can finish up this thing. We do 1, 2, 3. Yeah?
Okay.
Yeah, the guy in the blue shirt,
Yep.
go, shoot.
2 short questions. The one is, in the beginning you said, if you find a bug for a certain mobile phone, it usually will kill all the series of this. Like, if you have a bug for one Nokia phone, all the S40 Nokia phones are affected.
Can I
Was
stop
it
you
true?
for a second? Speak more into the mic and louder. No, like almost eat it.
Okay, I eat it.
Yes.
In the beginning you told us that you think if you find a bug, for example a Nokia phone, that all the Series 40 phones will be affected.
Yes.
Could you confirm that?
Well, that was based on our experiences. We usually tested one device for every manufacturer, and when we tested it on various other devices, they just behaved the same. So I haven't seen a phone that doesn't behave like this, and we tested quite a lot. So.
And for Nokia, we actually got, from them, we got the confirmation that everything that was built up to the end of last year is affected.
Okay. And the second question, is it possible to make these attacks from one mobile phone to another mobile phone?
Yes,
So,
I have Python scripts on my phone to send this to various numbers.
so the sending mobile phone accept the manipulated PDUs, and also the SMSC of the mobile operators will accept certain manipulated PDUs.
So all attacks were tested on real networks, like on all German operators. We tested all attacks sent from just one of our phones, and it works.
Yes, to answer this question, we tested all of these bugs over a real network, so it's no problem.
Yeah. And there was another guy standing there. No more questions? Oh yeah. Come on, shoot.
A question about attack mitigation. Would it be possible that mobile operators start filtering these PDUs for malicious
Yes.
content,
We
or would
have-
that amount to basically rewriting the operating software for
This is possible, but of course they have to know the payloads. And so far we have visited one manufacturer of SMS filter software, and there's a very powerful filtering software. But you need people who maintain this, and yeah, there's no thing as a central database tracking vulnerabilities. So it would work technically, but it would be quite a lot of work.
Do you think this would be possible theoretically, or is the SMS spec so much open-ended that this is just not doable at all?
Sorry, I didn't understand the question.
What you want? Yeah. So it would, of course, it would work technically, but so far we don't know about like people tracking bugs, and binary filtering is like not what all the filtering systems are made for. SMS filtering software that is at operators is made for filtering out bad words and text messages. So the binary stuff, they can filter it, but they have to like create one-to-one matching rules. So if you modify 1 byte in your binary message, they have to create a new filter rule. Do I have to say more?
Okay, thanks.
The last question, and then you guys can go.
Have you tried to combine these bugs so that you could maybe send one text message and bring down phones of multiple vendors?
No, but interesting idea. Thanks. No.
Okay. Thank you.
Okay, thank you very, very much.